Okay, here we have another question of whether something could happen randomly or whether there was something rigged going on. And notice this is a question that underlies the heart of statistics, especially statistics that's very useful in terms of medicine, figuring out if some kind of drug is actually effective or if it's just healing the same number of people that a random sugar pill would do, or whether it's some kind of injustice, as is being accused in this situation, where someone's controlling something that appears to be or is purportedly random, but actually isn't random. So in this situation, we have 50 tickets, and 6 of them belong to the cousins of this Newman's family. So picturing Seinfeld or something. He's trying to use the postal service to help him out here and win more than he should by chance. Out of these 50 tickets, the first one gets chosen as a cousin, and the second one gets chosen as a cousin. So suddenly everybody is suspicious, and Newman's comments are not very polite here. So let's investigate whether or not something is going on here. So what the first way of looking at it was a simulation. In other words, they simulated the original event, 50 tickets, 6 of them cousins, and they drew out 2 tickets 1,000 times. So each of those 1,000 times they drew 2 tickets, and what they were basically looking at is how many cousins do they get during these times. So 844 of these 1,000 double draws, they get no cousins. 149, one of the draws is a cousin, one is not. And only 7 out of the 1,000 do they actually draw 2 C's. So the theory here is called the law of large numbers. If we would simulate this event a large number of times, we'll get close to the actual probability, the theoretical probability that we should get by random. So what was the probability that we got in these 1,000 simulated drawings? Well, there were 7 of the times where we got 2 cousins out of 1,000. So in the simulation, 7 of the times did we repeat what actually happened in reality here. 7 out of 2,000. So 7 divided by 1,000 gives us 0.007. Okay, so that's what the simulation is telling us, approximate probability of this event happening. And notice this is less than that 0.025 criteria that was mentioned as kind of a cutoff for fairness, or that we can believe that it's random. So this is suspicious. Let's go ahead and calculate the theoretical, the actual probability. So this is a simulation. Now we want the actual theoretical probability of the cousins winning both tickets, or both prizes. So how would we get that? Well, first of all, we need to know how many different ways the cousins could win. So let me pull up a, this is going to get ugly, but I hope you'll bear with me here. So yeah, that's not going to work. Okay, let's just try it here. So there's 2 different ways to approach this problem. Let me show you both of them. The first would be if we consider the different ways that the cousin could win. So notice that there are 6 tickets that the cousins have, and we want to know all the different ways we could choose 2 out of those 6 tickets. So this is getting back to the combinations, and I believe I talked about this in video, it was either 1.2 I think 1.2 E13 or 1.1 E7. Sorry, I'm not sure. But this is a combination. So in other words, this is the same as having 6 factorial over 2 factorial times 6 minus 2, so that would be 4 factorial. And if you work all of that out, you would get 15. In other words, there's 15 ways that the cousins tickets could have been drawn. They have 6 tickets to choose from. There's 15 different ways to choose 2 out of those 6 tickets. Now if we put all of this over the total number of possibilities, so in other words, there's 50 tickets to draw from, and we're going to choose 2 of them. So this includes all the different ways we could get 2 cousins, 1 cousin and a not cousin, or 2 tickets that are not the cousins. This includes all of those options. Because we have 50 options, we're choosing 2 out of the 50 tickets. If we work out the factorial, notice that I'm going to do a shortcut. I know that I'm going to have 50 factorial on top and 48 factorial on bottom. So I know that 48 factorial will cancel out almost everything in this 50 factorial except for the first 2 entries. So from here on out, I would have 48 times 47 times 46, but I would also have that in the denominator. So those 2 are going to cancel out, and I just have 50 times 49 on the top. On the bottom, I have 2 factorial, but 2 times 1 is just 2, so I'm writing that as 2. If I work that out, I would get 12, 25. So this would give me an answer. And notice I can divide top and bottom by 5 to get in lowest terms. And that would give me my answer of 3 over 245. Now I do want to show you another way to approach this. So this is looking at all the possible ways of getting the cousins tickets, all the possible ways of getting any 2 tickets. Another way we could approach it is, what's the probability that that very first draw will be a cousin winning? Well, there are 6 cousins tickets and there are 50 total tickets. So 6 out of the 50 would give us a cousin winning. Now, after that happens, and this is what's called an independent event, so we're multiplying. Actually, I shouldn't call it independent. We're wanting to know what happens assuming that a cousin won on the first one. What's the chance that a cousin would win on the second draw too? Well, now we only have 5 tickets left for the cousins because we already picked one right here, and we only have 49 to choose from because one has already been chosen. Okay, and if we multiply those fractions, now we could divide both of these by 5 right away. That would save us some reduction heartache later, but let's say we don't do that. We would get 30 out of this is painful. I will research a better way to do this. Okay, so we'd get 30 out of 2450. We cancel the zeros there. In other words, divide both top and bottom by 10. We'd get 3 out of 245, which again is another way to get the answer to part B. Wiley here is showing off its alphabetical abilities by going to A to D. But the answer is indeed 3 out of 245, which if you calculate is not far off of this 0.007, and it's still below that 2.5% cutoff, suggesting that there may have been some funny business going on here with this drawing.